we would allow it to grow slightly, but we don't want it to grow significantly. Right? This is, kind of goes perhaps is related to model capacity, where you have an initial setup that is model that has been trained for a certain number of tasks. But now if you want to add more tasks, perhaps the initial architecture that you have is not sufficient. Right? You might have to extend it slightly, but you don't want to extend it significantly. Right? So that's some change that we're going to allow. The other one we're going to do is, okay, we don't want to forget, but instead of forgetting, we'll say we don't want to completely forget. Obviously, there might be some forgetting that will happen, but we would like to avoid it as much as possible. Okay, so these are the required properties that we are looking for, in any incremental learning algorithm. Okay, so now given this, we're going to look at different methods. As you saw with meta learning, this topic of incremental learning has also been treated in different ways, and we're going to see examples from each of these, let's say, paradigms of methods for incremental learning. So the first one is called as regularization based. So what I said is, when you're training your new task or your new classes, what we would like to do is have some sort of way of keeping all the information that you have from your old tasks. So we might want to regularize, for example, by modifying the loss function to incorporate some information from your old tasks. Okay, so that is the first kind of class of methods. The second one is that of rehearsal replay methods. So this is the case where we'll allow some of the samples to be stored. We don't want to store all of the data, but we'll perhaps allow some of the data from the initial or the old tasks or classes to be stored. Okay. The third one is related to, I think, network architecture was one of the questions. Perhaps the architecture that you have initially is not sustainable to keep increasing the number of tasks and classes that you're trying to learn. So we will allow some sort of architectural changes to happen, as part of this incremental learning setup. Okay. So this is these are the three classes of methods that we'll be looking at, and a few examples in each of them. Okay, so any questions so far before we continue? Yes. So the replay methods, we'll deal with each of these methods. So we will discuss all the methods. So that will be just after. Okay, there was one question there. So the base network is trained with classification. Okay. Okay. So that is, I guess, one setup of incremental learning, but that requires some other. We'll deal that question maybe offline, because it's not directly in these. So here we are dealing with a setup which is a class incremental learning setup, where I'm just giving you additional classes for the same problem. So I'm still within, let's say, the classification space of problems, but I'm just adding new classes which I have not seen in the past. So what you're referring to is a slightly different one, where you're completely changing the problem itself, a related problem, but not the same. So that requires some other changes. So that will require significant. So it will be not just changing the architecture of the network, but doing additional things. So we will take this offline when we go to maybe the more advanced. Yes. Again, the same thing. The task is changed from classification to detecting objects, or even to segmentation of the objects. So that will require more changes. So maybe we can take that after we do the second talk as well. So what you're saying is also sort of on the borderline of incremental learning, but here we are focusing on the case where only classes are being added for the same problem. Okay, so we are remaining in the space of classification, or I could start with detection and I want to add new classes that I want to detect. So if we go back to the previous one, so here domain adaptation, simple thing is, let's say you have detected, you've learned your network for classifying natural images, like images of cats and dogs and different objects, but now I want to do classification on, let's say, medical images, right? So you have a completely different domain again, they are images, so you're still trying to achieve or solve the same problem of classification, and but it's just that the domain has completely changed. Okay, any other question? Okay, so let's move on. So we'll start with the regularization-based models. So here, what we're going to simply do is when you're training a new task, we're going to add a regularization term, to the loss function. So when you're training, you have a loss function. So what we're going to do is modify this loss function with regularization terms. And this regularization term will essentially penalize all the forgetting that is happening on the old classes. So it is penalizing the catastrophic forgetting that you have. Okay, so even within this space of regularization-based models, you have two different classes of regularization that is possible. The first one could be data-focused. Okay, so we're going to compute this regularization term based on the data. Okay, so the data that we are training the model on. The second class of regularization comes from sort of the model, the prior that you have for learning the models. Okay, so we'll see examples of these two regularizations. Okay, so the first one, which deals with regularization in terms of data, is that of knowledge distillation loss. So this essentially is a loss that was proposed several years ago, 5-6 years ago now, from Geoff Hinton, which essentially was initially done for, let me just see. Okay, so this model was initially proposed. This loss, let's say, of distillation was proposed when, let's say, you have a huge network that has been trained with lots and lots of data, has millions and billions of parameters. So that model has been completely trained offline. Okay, so now you want to deploy this particular network on a let's say an embedded device or a small chip which doesn't have that much computation power to kind of compute all the operations in this large network. So what you'd like to do is, let's say, condense this initial network into a much smaller network, but then not lose too much of the performance. Okay, so you would like to distill whatever has been learned in this large network to a much smaller network. So to keep the performance comparable, obviously you will lose some performance, but you'd like to still distill all the things that has been learned from a larger network to a smaller network, as much as possible. So this was the initial idea of distillation.
So,
yes.
How is knowledge distillation different from pruning?
So pruning, you can say is one way of maybe kind of doing your distillation. Okay. So, but there are other ways of doing distillations. So pruning, what essentially that does is, let's say you want to prune your network itself. Okay. So here, I have, let's say, given you the network, the new network that I want to achieve, but I'm just going to change the loss function. Okay. So in the case of pruning, what you're doing is actually actively choosing parts of the network and then building your own new network. But then, let's say, given the constraints that I have on my embedded device, I give you the network that I want. Okay, so the network has now been given. All you're able to do now is just maybe adapt the loss function between these two networks. Okay, so pruning will be when you're modifying, let's say, the architecture itself directly. Okay, so this idea of knowledge distillation was kind of essentially used in this particular concept for incremental learning, where what we're going to do is, okay, I'm going to define a new loss function which essentially distills everything that I've learned on my old data to when I'm learning this new set of classes. So you can have two parts to your loss function. So I've avoided the equation because I'll come back later in the afternoon and we'll see in more detail at that point. So essentially, what's important to learn here is you now modified your loss function, your training loss function, by adding a new term, which is this distillation loss, which essentially computes what is the forgetting that is happening on your old set of classes. So that is a small addition that has been done to your loss function. So the good thing about this is, this model is very simple and it has been shown to give pretty interesting and good results, but when the tasks are related. So this initial work from about 3 years ago was essentially tested on, sort of, I would say, more like a domain adaptation kind of task where you have, let's say, image classification that is happening on Pascal VOC, one of the popular image classification data